Okay, our last example for week 4 is a paired test for difference in means. So notice I'm in the paired tab on our confidence intervals and hypothesis testing sheet. Okay, so multiple myeloma or blood plasma cancer. Basically, we are looking at the bone marrow microvessel density. So one of the few ways to treat cancer in the blood is to do a bone marrow transplant. And the idea here is that whenever you give the bone marrow transplant, we expect to see the microvessel density decrease. So what this is testing is whether there is evidence whether the mean bone marrow density is higher before the stem cell transplant rather than after. So we've got the data right here. We've got patients 1 through 7 and the before and after numbers. So as usual, I'm going to paste in our template. So I'm going to go over to our template file. Notice that I have paired down here. So I'm just going to highlight all of this, copy, go over to cell A1 and paste it in. Okay, and then we need to paste in our data. So I'm just going to grab this, paste this over, get rid of these. Okay. So let's just look and make sure all of these are updated. So this is now from row 2 down to 8. So this is still going down to 11. So let me change this to 8, change this to 8, and change this to 8. All right, those have all been updated. The null value is 0. Level of significance is 0.05. Now we expect the density to be higher before after. So if we do before minus after, we expect to see a positive difference. So here this one increased, but here, that's fine, this one decreased from 202 to 101. And so this is a positive difference. So when we look at this, we know that this is going to be greater than, and then for the null we would do insert symbol less than, and okay, our hypotheses are good to go. And this is a one-tailed test, so that means we don't care about the two-tailed numbers. And we see that the p-value is 0.057, which is not less than 0.05, so it's close, but still it's not less than 0.05. And so for our conclusion, we fail to reject H0. For assumption, we know that this is not independent, this is dependent samples, but we still need population of differences are normally distributed, and it is norm, and the samples have equal variances. And actually, technically, it would be populations. And then we also have our upper and lower bounds down here. And okay, we're done. I mean, we've now done our test for dependent samples. So last thing I'll do is just quickly show you, for those who weren't in my first class, if you want, you can earn some extra credit if you just make your files neat when you hand them in. So let's say I'm making a file. So I might put my name, say homework 1, say problem 1. Let's say we were asked to do a hypothesis test. So I would just copy and paste this in. And then if we were asked about our conclusion, I would say we failed to reject H0 because p-value equals 0.057 is greater than 0.05, which is alpha. And then we would probably give our interpretation. I won't write it out here. And then let's say like part B was to do the confidence interval. So I might paste this in, and I'd say we are 95% confident that the true difference in means is between -28 and 200. And so on. And then I would do file, save as, and I would save it as homework 1, and then hit save. And that's what I would use to submit. And then I'm also going to have to submit my Excel file. So if I were to submit this, okay, I have these titled differently, but I would say title this as problem 1, and then I would save this as homework 1, and it'll be saved as a .xlsx file. Well, this one is saved as a .docx file. And so basically what I'm saying is if you make my life really easy in terms of grading, because everything is neat, organized, it looks decent, I will give up to 3 credit bonus points on each homework if you can do that. So basically something like this. And if you want, you can also you can submit this as a Word document or a PDF. I don't care. So, all right. Well, that is all for week 4.